This video will be on trig functions on the unit circle. So in geometry, we learned that trig functions were defined in terms of a right angle. Now we can define trig functions in terms of the unit circle, which allows us to extend those trig functions to all real numbers. Now from geometry, recall the phrase SOHCAHTOA, meaning that sine is in terms of opposite over hypotenuse, cosine is in terms of adjacent over hypotenuse, and tan is in terms of opposite over adjacent. So we can use that phrase to help us define sine and cosine of a real number related to its position on the unit circle. So we know that sine of theta equals opposite over hypotenuse, thus opposite equals hypotenuse times sine of theta. We know here that the radius is always 1, so that means that the hypotenuse is always 1. That means that just opposite equals sine of theta. The opposite side is y, therefore y equals sine of theta. Y equals sine of theta, which we see here in the point with the y being related to sine of theta. Next, for cosine, we know that cosine of theta equals adjacent over hypotenuse. Thus, adjacent side equals hypotenuse side times cosine of theta. Hypotenuse side is 1, so therefore adjacent side just equals cosine of theta. Adjacent side here is x, therefore x equals cosine of theta. X equals cosine of theta, which we see here with the x point being related to cosine of theta. And then finally, for tan of theta, we just know that it equals opposite over adjacent. So if we wanted to find the angle measure and we had the opposite side and the adjacent side, we could do inverse tan on both sides and we would get that theta equals inverse tan of opposite over adjacent. Now this allows us to get to the idea that the cosine of a real number t is the x-coordinate of its terminal point on the unit circle, and that the sine of a real number t is the y-coordinate of its terminal point of the unit circle. So if we were given an angle negative pi over 6 and we were asked to find both of its points, first we would try and find one of the coordinates, say y, so we would do sine of negative pi over 6. We know that negative pi over 6 is just 11 pi over 6 because it's going clockwise instead of counterclockwise. We know that 11 pi over 6 is in the fourth quadrant, that means the y has to be negative, and we know that the point for pi over 6 is square root of 3 over 2, 1/2. So we know that sine of negative pi over 6 is negative 1/2, and thus cosine of negative pi over 6 is square root of 3 over 2, and thus we know that the terminal point of negative pi over 6 is square root of 3 halves, square root of 3 over 2, negative 1/2, which makes sense as in the fourth quadrant, the x-coordinate is positive and the y-coordinate is negative. And now adding on to that, we can also be asked to find the values of x in the interval 0 is less than or equal to t, which is less than or equal to 2 pi, meaning that just t, the angle, is on the interval of 0 to 2 pi, that satisfy each equation. The first one is cosine of t equals 1. We know that cosine equals 1 at 0 and 2 pi. And then for sine of t equals negative square root of 3 over 2. We know that that thus has to mean, since sine of t is related to the y, that this has to be in the third or fourth quadrant. And we know that sine of an angle can only equal square root of 3 over 2 when the angle has a reference angle of pi over 3. So thus, if this has a reference angle of pi over 3 and it's in the third or fourth quadrant, t has to equal 4 pi over 3 or 5 pi over 3. Now we have cosine of t equals negative square root of 3 over 2, negative square root of 2 over 2, sorry, and square root of 2 over 2 can only be the x-coordinate when an angle has a reference angle of pi over 4, and the cosine is negative, meaning that it is on the left side of the unit circle, means quadrant 2 or quadrant 3, so thus t has to equal 3 pi over 4, 5 pi over 4, and then finally sine of t equals 1/2. We know that it's positive, and if sine's positive, the y-coordinate is positive, so thus this has to be in the first or the second quadrant. We know that sine is only equal to 1/2 when the angle t has a reference angle of pi over 6. Thus, if it's reference angle of pi over 6 in the first or second quadrant, t has to equal pi over 6 or 5 pi over 6. Going back to the relationship of tan being equal to opposite side over adjacent side, we can use this to define tangent in terms of sine and cosine. Since sine equals opposite over hypotenuse and cosine equals adjacent over hypotenuse, when you put sine over cosine, the hypotenuses cancel out and you're left with opposite over adjacent, which is tan, so thus tan equals sine over cosine, where cosine of t cannot equal 0, because if cosine of t equals 0, then tangent would be undefined. Therefore, tangent is undefined at the 2 points of 0, 1 and 0, negative 1, which are also pi over 2 and 3 pi over 2 respectively. So here is a couple practice problems dealing with that tan relationship. So tan of 2 pi, we know that 2 pi, the coordinate for 2 pi is 1, 0. So that's sine is equal to 0, cosine is equal to 1. Therefore we get 0 over 1, which is equal to 0. At 7 pi over 4, we know that that's in the fourth quadrant. So the point has to be square root 2 over 2 comma negative square root 2 over 2. So we put sine over cosine. Therefore we get negative square root 2 over 2 over square root 2 over 2, which square root 2 over 2 is equal to square root 2 over 2, so it's just negative 1. For tan of 7 pi over 3, this one's a little bit more tricky because you first have to figure out where it is in the unit circle. So 7 pi over 3 is going to be greater than 2 pi because 2 pi is equal to 6 pi over 3. So you subtract 2 pi from 7 pi over 3. That would get you a reference angle of pi over 3. Thus, you know that the point here is just 1/2 square root 3 over 2. And thus, if we put the square root 3 over 2 over the 1/2, you would get 2 square root 3 over 2, which would just get you square root 3. And if you wanted to show your work with that, you know that square root 3 over 2 over 1/2, you know that the 2's would just cancel out. So thus you would just get square root 3 over 1, which is just square root 3. And then finally with tan of 7 pi over 6, you know that 7 pi over 6 is in the third quadrant, so thus both the sine and cosine are negative. And thus for pi over 6, we know that the point is square root 3 over 2, 1 over 2. So thus 7 pi over 6 has a point of negative square root 3 over 2, comma negative 1/2. So we do the negative 1/2 or the sine over the negative square root 3 over 2 or the cosine. And we would get 1 over square root 3 because the negatives cancel out and the 2's squared out. The 2's cancel out. And we know that 1 over square root 3 can also be written as square root 3 over 3 if you multiply it on top and bottom by square root 3. And thus, this is all you need to know about trigonometric functions on the unit circle.